Hi students, today we're going over Unit 4, Module 3, Session 5, called Maria's Multiplication. Number 1 says Maria is practicing solving problems using the standard algorithm for multiplication. She knows the first step, but then she gets stuck. Finish these problems Maria started. So we see number 1 that she multiplied 8 times 8 and got 64. What does she do next? Well, we know that then we take 8 times 3, which is 24. Add the 6 up top, which is 30. And then we're done with the 8 in the ones place. So we hold the place value, move to the 2. 2 times 8 is 16. So we record the 6 in the ones place, carry the 1 up top. 2 times 3 is 6, plus 1 is 7. And we add. We have 4, 6, 7 plus 3 is 10, so our answer is 1064. Let's look at the next one. 7 times 4 is 28. Then we move to 7 times 8 is 56, plus 2 is 58. We're done with the 7, so we hold our place value. 3 times 4 is 12. 8 times 3 is 24, plus 1 is 25. We add our partial products. Oh, the answer is 3,108. The next one, we see 7 times 6 is 42, 7 times 2 is 14, plus 4 is 18. We're done with the 7. Hold the place value. 9 times 6 is 54. 9 times 2 is 18, plus 5 is 23. We add our partial products. We have 2, 12, 5, and 2. 2,522. Number 2, we see fill in the boxes to complete the problems. Number 2 says fill in the boxes to complete the problems. We see 1 times 3 is 3, 1 times 2 is 2. Then we're done with that place value. So 1 times 3 is 3, 1 times 2 is 2, add the partial products, 3, 5, and 2. Next one, 2 times 5 is 10. Carry the 1. 2 times 1 is 2, plus 1 is 3. Done with that place value, that's why there's a 0 or an x, means the same thing. 1 times 5 is 5, 1 times 1 is 1. Fill in the answer, we have 180. We're ready for number 3. Number 3 says, Conrad always likes to use the standard algorithm. He has to solve 99 times 38. Can you recommend another strategy to Conrad that might be more efficient? Explain. So what do you notice here about these two factors? I notice that 99 is close to 100. So I would use the over strategy, and I would take 100 groups of 38, which I know that is 3,800 or 3,800. And then I would subtract one group of 38, which is 38. And so our answer would be 3,762. So you're going to write that because you need to explain it. Perhaps you would use the over strategy. Number 4, the challenge says Lydia also likes to use the standard algorithm for multiplication. She has to solve 32 times 8 and 25 hundredths. Recommend another strategy to Lydia and show her how to use that strategy to solve this problem. So perhaps I would break it up and do partial products, and I would take 32 times 8 and then solve 32 times 25 hundredths, because for that I can think 1/4 of 32. So let's first take 32 times 8. Now that's too difficult. I can think 32 doubled, doubled, doubled. So 32 doubled is 64. 64 doubled is 128. 128 doubled is 256. So 32 times 8 equals 256. 32 times 25 hundredths, I can also think of 32 quarters, is $8. So what's 256 plus 8? Because now I'm adding those two partial products, and the answer is 264. But now the question asks to recommend another strategy. And what's this strategy called? Partial products Because I'm breaking up 8 and 2500ths to 8 and 2500ths. Looking at number 5, we see finish the number pattern for the rule 2n plus 1. So we're thinking 2 times 1 plus 1. So 2 times 1 is 2, plus 1 was 3. Then we take the number 2 and insert it in for n. 2 times 2 is 4, plus 1 is 5. Then we take 3 and put it in there. 3 times 2 is 6, plus 1 is 7. Then we take 4 and put it in there. 4 times 2 is 8, plus 1 is 9. Do you see a pattern? Yes. It looks like it's all odd numbers, or we're counting up by 2. That is correct. We can double check our work by thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's add 10 into n. 10 times 2 is 20, plus 1 is 21. Let's look at number 6. Finish the number pattern for the rule 4n plus 1. So 4 times 1 is 4, plus 1 is 5. 2 times 4 is 8, plus 1 is 9. Let's take 3. 3 times 4 is 12, plus 1 is 13. 4 times 4 is 16, plus 1 is 17. And then we go 5. 5 times 4 is 20, plus 1 is 21. So it looks like we're increasing by 4 every time. And so we're going to have 25, 29, 33, 37, 41. Number 7 asks, what do you notice about the 2 number patterns you just completed? How are they similar? How are they different? So perhaps you can notice that they both have only odd numbers. Maybe you can notice that all the numbers in the second pattern appear in the first pattern. Maybe you notice that every other number in the first pattern is a number from the second pattern. Or perhaps you notice that in the first pattern you add 2 to get to the next number, and in the second pattern you add 4. So you're going to go ahead and write one of those observations, or you have perhaps your own. Let's look at number 8. We're going to multiply 8 and 7/10 times 10. So that's going to equal 87. 8 and 7/10 times 100, 870. 8 and 7/10 times 1,000. Do you see a pattern here? 8 and 7/10 times 1/10 is going to be 87/100. 8 and 7/10 times 1/100th would be 87 thousandths. So if you think about place value, this will help answer your next question. Look at the zeros and the decimal points in your answer. What do you notice? Well, I notice that when you multiply by a whole number power of 10, like 10 or 100, you move the decimal to the right by the number of zeros in the power of 10. When you multiply by a power of 10 less than 1, like 1/10 or 1/100th, you move the decimal point to the left by the number of digits to the right of the decimal point. So for example, if we're thinking of place value, and we put in 8 and 7/10, like in A, we're multiplying by 10. What happens to this decimal point right here? That's right, it moves right there, because now our answer is 87 whole numbers. So this 7 is no longer in the tens place, it's now in the ones place. The 8 is no longer in the ones place, it's in the tens place. So it shifted how many place values? One place value, because there's 1 0. So you're going to explain something to that effect here in F. And that's all for today.